Good afternoon and happy Friday. We are Hycomp, manufacturer of oil-free reciprocating compressors up to 250 horsepower. And this is our webinar presentation of Gaining the Laser Cutting Competitive Edge. I am Kelly Gifford. I work with the sales team here at Hycomp as an account manager, and I'm here with two of our technical experts with regards to our compressors, Mr. Ken Schieffer, who also works as an account manager, and Mr. Robert James, our president and CEO. We would like to thank you for choosing to spend part of your Friday afternoon with us. We know your time is incredibly valuable, so we're going to move through things pretty quickly today. We have a lot to cover in a very small window of time. We will welcome your questions and feedback. Please use the chat feature to type your questions as they come to you, but please be aware, in the interest of time, we are going to wait until the very end to answer those questions. We do invite you to stick around for the duration of the webinar to hear about the follow-up sales toolkit that will be released next week. Our goal today is to provide you information and tools to succeed in the growing laser cutting market. And with that, let's take a look at some of the market information as it relates to laser sales. According to an article issued by Industrial Laser Solutions for Manufacturing, revenues for laser cutting rose nearly 5% in 2015 and are projected to continue in a similar growth pattern over the next several years. We can see here that laser revenues increased from $1.42 billion in 2015 to a projected $1.56 billion in 2017. That's incredibly significant. Laser sales have been on the incline since the recovery from the 2008-2009 recession. However, improvements to the fiber cutting laser technology over the past 3 or 4 years have created a demand in this market surpassing previous trends. More specifically, industrial lasers have been outperforming the machine tool sector for the past 2 years. Again, this is due to the demand for high-power fiber lasers. Speaking of lasers, let's talk about the couple different types that we're going to use for today's discussion. There is the fiber laser, the CO2 laser, and then for today's discussion, we're going to call the other category just other. We can see from the chart that fiber lasers are 44% of the market. Why? Their increased efficiency means they cut faster. Decreased energy means they're less expensive to operate. Although fiber lasers have been around for several years, the technology has improved drastically over the past 3 to 4. In fact, it's interesting to note at power levels from 8 to 12 kW, the fiber laser can cut with the same quality as the CO2 laser, only faster. I had the opportunity last year to visit FabTech in Las Vegas. It was great to meet many of our customers, and I had a great experience. I was excited to come back and share what I learned with my colleagues here at Hycomp. According to 5 of the top laser manufacturers, being Trump, Amada, Mazak, Bystronics, and Mitsubishi, they forecast a combined 800 new fiber laser systems into the USA this year, with an additional 100 in Canada, Mexico, and South America. This number should increase to 900 in 2018 and 1,000 in 2019. They're not seeing any pattern for slowing down the new fiber laser sales in the United States. Keep in mind, there's a strong possibility that 50% or more of the new laser owners will be able to justify in-house generation based on their nitrogen consumption and usage. We will get into more details about assist gas in a moment, but I wanted to highlight the real opportunity in this market. One of the other interesting facts I noted at the show is that there was only one CO2 laser on display. We can see the fiber laser is taking over this market. Now we're going to take just a minute, turn it over to Robert, and he's going to discuss how lasers actually work.
So let's take a little bit of time and talk about the basics of laser cutting machines. Many people don't know that the word laser is really an acronym that stands for Light Amplification by Stimulated Emission of Radiation. Quite a mouthful for a freaking laser. A simple laser consists of 3 parts: an energy source to excite the electrons. In most cases, that energy source is a high-powered light like a flash tube in your camera. The second is the lasing medium, which is the material, like CO2 gas, in which the atoms are excited, producing photons that are the actual laser light. It is important to note that laser light is not the light from the flash tube. It's actually the light produced in the lasing medium. And finally, we have the resonator, which is a set of mirrors that bounce the photons back and forth that are emitted from the lasing medium. In simple theory, the flash tube injects high energy light into the lasing medium. The light excites atoms in the medium, which subsequently emit photons. Now, those photons are identical in wavelength, what we see as color, and are coherent, meaning that their wave crests and valleys are aligned. The photons resonate back and forth off the mirrors, and those photons passing through the lasing medium stimulate additional photon emission in other atoms. Finally, laser light is emitted through the partially mirrored end, which is often referred to as the optic coupler. One of the most common lasing mediums in the laser and cutting industry is a CO2 gas mixture, hence the term CO2 laser Kelly mentioned previously. These laser cutters utilize the same basic concept of a resonator, lasing medium, and light pump to create the laser light. A beam bending mirror then directs the laser light to the workpiece. A focal lens intensifies the laser light to a fine point. The assist gas, which is what we're mostly interested in today, protects the lens and sometimes the mirrors and cleans the cut of molten metal. And finally, the focal point is the maximum focus point for the greatest heat. Now, one thing to remember, a real CO2 laser is certainly more complicated as the cutting head must move around a 4 by 8 foot piece of material. So many mirrors are utilized to direct the laser light to the cutting head. Fiber lasers are similar in concept but different in design and build. Instead of a flash bulb as the energy source or light pump, they utilize laser diodes, which are similar to a high-energy LED that many of you are likely familiar with. Perhaps the biggest difference is the lasing medium and resonator. Rather than CO2 and mirrors, a fiber optic cable is utilized. The fiber optic has been embedded with rare earth elements, often erbium or yttrium, and it is these rare earth elements that are the lasing medium. Now, the fiber has small pieces of etched glass at the two ends that refract the light created from the rare earth elements, thereby acting as mirrors and causing the photons to resonate and increase energy. There is still a focal lens to intensify the light to a single point. Assist gas is actually more critical because a fiber laser has a much higher power density than a CO2 laser and therefore requires even more gas to blow out the cut in order to take full advantage of the possible cutting speed. And certainly there is a focal point where the laser light is most focused in order to produce the most heat. Assist gas is actually a bit of a misnomer because it's really more of a partner than an assistant. As we saw, assist gas is necessary regardless of the type of laser, and it performs several functions. First and perhaps foremost, it protects the focusing lens from debris and damage. Next, it evacuates the molten metal from the cut. It's important to remember here that a laser doesn't vaporize the metal, it actually just melts it. And in order to achieve maximum cutting speed, that molten metal must be removed quickly. Finally, in some cases, assist gas will actually aid in producing a hotter focal point, allowing for cuts in thicker materials. There are three basic types of assist gas in use for laser cutting: oxygen, nitrogen, and air, which is of course 78% nitrogen, 21% oxygen, and balance argon, CO2, and other gases. Now, oxygen is actually exothermic, meaning it has a heating effect when used as an assist gas. Not surprising if you're familiar with an oxyacetylene torch. But this means that the laser can utilize oxygen as the assist gas in order to cut thicker materials, as it in essence increases the power of the laser. Conventionally, it has been used on mild steel with thicker materials, although it has been used successfully on thick stainless as well. The pressure and flow requirements are fairly low, with pressures ranging in the 20 to 28 psi range. In fact, too much pressure or flow will cause the cut to widen significantly, leading to poor cut quality and dimensional failures. Of course, the downside to oxygen as an assist gas is that it leaves a heavy amount of oxidation on the cut edges, requiring a significant amount of post-production work. Air has seen some popularity recently as assist gas. It actually has a cooling effect, which is not surprising when you think about a burst of air over molten metal. It's going to solidify that metal. Conventionally, it is used on thin carbon steel, where the edges are small and oxidation is limited. It also sees use on aluminum, since the small amount of aluminum oxide formed is clear to white and can actually give a nice looking protective coating to the finished part. Significantly higher pressures and flows are required than with oxygen, and since it comes off a compressed air system, great care must be taken to ensure no oils are in the assist air. Obviously, there will still be some oxidation, but generally not considerable amounts, as air is still 78% inert nitrogen. Our final assist gas, and the one that we're really here to talk about, is nitrogen. Nitrogen has a similar cooling effect to air. Conventionally, it has been used on thinner stainless materials. I'm sure you understand that no one wants rust on their stainless parts. But with the advent of the more powerful fiber lasers, lower cost in-house nitrogen generation, and the push to move away from post-processing operations like oxidation removal, you're going to start to see nitrogen used on carbon steel applications as well, which is obviously exciting for us as an industry. Similar to air, high pressures and flows are required, again, especially for fiber lasers, as they are capable of much higher cutting speeds and need that molten metal evacuated quickly. And certainly similar purity requirements exist to ensure a clean lens and clean cuts. The obvious big benefit is the entire lack of oxidation when utilizing nitrogen. We see a huge potential over the next few years for in-house nitrogen generation and find this to be a pretty exciting time for this product line. So how much assist gas is required? Unfortunately, it varies widely. Things like material, whether you're cutting stainless, carbon steel, or aluminum. The thickness of that material. Thicker materials require more assist gas to evacuate the molten metal. Nozzle size. You may be familiar with flow through an orifice. Well, that's really all this is, and just like an orifice, the flow rate increases exponentially with size. For example, a 3 millimeter nozzle uses twice the flow of a 2.5 millimeter nozzle. And finally, cut speed and edge quality will affect how much gas your customer uses. For example, let's take a look at a general chart for cutting stainless steel with nitrogen. As we range from 80 thousandths to 1 inch thick, the pressure required more than doubles from 135 to 320 psi, while the flow required goes up by nearly 8 times from 420 SCFH to 3,120 SCFH.
Real quick, this question, how much nitrogen do you need, is really the key question to help us understand if your customer can justify the in-house nitrogen generation. So this piece of the puzzle is key, very important.
Absolutely. Return on investment is going to almost entirely depend upon how much gas the customer is using,
right,
and the cost of that gas. All right, another important aspect to consider is the purity of that nitrogen. One of the terms you're going to come across is 4,9 or 5,9 purities. This is generally in reference to the amount of oxygen present in the gas. To clear the proverbial air, 4,9 is 99.99% nitrogen, or less than 100 ppm of oxygen, while 5,9 is less than 10 ppm of oxygen, or 99.999. Another concern with nitrogen purity is the amount of hydrocarbons present. Oils are an absolute no-no when it comes to laser cutting. Standard recommendation for laser cutting cleanliness is ISO 8573.1, Class 1, which has a limit of less than 0.008 parts per million of hydrocarbon. That's 8 parts per billion. Purity affects the cut quality of the workpiece. Unwanted oxygen leads to rust on the edges of a stainless or steel part, and oil in the assist gas will cause the laser to burn hot, resulting in poor cut quality. Either of these two purity issues lead to additional post-processing costs. The larger concern, however, is with oil damaging the optics of a laser. If the lenses or mirrors of the laser are covered in an oil film from the gas, two major problems will occur. The first is a decrease in laser efficiency due to scattering of the laser light, which means slower cuts and higher cost per part made. But worse, once an optical lens or mirror gets dirty, they will begin to retain heat from the laser, which then warps that optical piece. As you can imagine, that means the optical device must be replaced. So what's the cost of contamination? A simple optics replacement can run $15,000 to $18,000. If it gets really bad, a full CO2 cutting head replacement is $35,000 to $50,000, while a fiber laser cutting head replacement can run up to over $100,000.
I'll share with you on this note a quick report from an end user, a laser user. $250,000 of damages due to a filtration failure that did allow some hydrocarbons to contaminate the laser. To put that into perspective, the average CO2 laser is $900,000 and the average fiber laser is $1.25 million. So $250,000 in repair due to contamination is quite significant.
Certainly makes us understand why it's so important to have pure, clean gas for that customer.
Correct.
So at this point, I'm going to turn the time over to Ken to talk about sources of nitrogen assist gas.
Thanks so much, Robert. And understanding how the laser works will give our attendees confidence when presenting to their customers. Let's talk about the various sources of nitrogen and how they're different. Bulk nitrogen is delivered in two forms or phases, liquid or gas. The advantage of bulk nitrogen is you are guaranteed the purity of the gas. I want to share with you some of the cons of bulk nitrogen delivery. First of all, logistics and safety. Nitrogen delivery is an added labor for you, your customer, and is provided in high pressure tanks. Typically, DOT bottles are about 2200 psig, maybe even higher. Safety is always a concern when you're dealing with high pressure gas, toxic gas, along with potential delivery accidents. Typically, there are delivery charges each time the gas is provided from the bulk provider. Most bulk providers have your customer sign long-term contracts. Your customer may or may not like their contract years later. Exiting a bulk nitrogen contract typically is not easy and frequently requires long advance notice. And then, of course, you've got that monthly bill. Let's talk about liquid nitrogen delivery. Nitrogen in liquid form is minus 321F or minus 196C. The liquid nitrogen then moves to the heat exchanger where the nitrogen temperature is raised. In the gas phase, the nitrogen is regulated to a usable pressure. Bulk nitrogen is typically delivered in high-pressure DOT cylinders. This is very common to those who are low users of nitrogen. The pressurized cylinder is depleted until you reach the pressure used by your laser. Consequently, the remaining gas is returned to the vendor, even though your customer has already paid for it. Now let's look at how bulk nitrogen compares with in-house generation, and we're going to speak in terms of 100 cubic feet in pricing. Basically, high-pressure cylinders are about $1 to $2 per 100 cubic feet of nitrogen. Bulk liquid is less expensive at about 50 cents to 75 cents. Now, this is what is significant.
Wait for it.
Thanks, Kelly. Drum roll, please. In-house generation is about 12 cents to 15 cents per that same 100 cubic feet of nitrogen.
And we've just had a report recently of as low as 8 cents per 100 cubic feet for in-house generation.
Kelly, that's huge. In-house generation, you can get a return on investment as short, depending on the customer's usage, of 1 to 2 years. But here's another thing and another aspect to look at. If you finance your equipment, the monthly cost may be less than that bulk price. And the beauty is you own that equipment once it's paid for, and you don't have to keep paying that monthly bill that I mentioned before. Now let's talk about the different methods of nitrogen generation. A method of in-house generation, one of them, is accomplished by a membrane. You're able to receive, I'd say about 95 to 99.9%, or as Robert stated, 3 nines in purity. Consequently, membranes are not often used in laser cutting. Compressed air enters the membrane from one end. Oxygen then escapes out through the sides of the membrane filters. Nitrogen continues through the membrane and exits out the other end. The other standard within laser cutting is the PSA, or pressure swing adsorption generator. As Robert mentioned, 78% of air is nitrogen and 20.9% of air is oxygen. So what you do is you force air into a sieve bed. The sieve bed contains carbon molecular sieve, or CMS.
And quick fun fact
Yes, Kelly.
on the CMS, it happens to be made of coconut shells.
Oh, man.
I love that fact.
Kelly, I probably wouldn't have made it through the webinar without knowing that.
Coconut fibers, to be exact.
Yes. Well, these coconut fibers, or holes in the CMS, are so small that the oxygen molecules pass by them and get captured inside the cavities in the mold sieve. The nitrogen molecules remain outside and are separated from the oxygen. Once the separation occurs, the free-floating nitrogen molecules are released at low pressure and captured in a surge tank. Once the nitrogen leaves the sieve bed, the pressure is released quickly, allowing the oxygen to escape into the air. The sieve bed is now ready for the next cycle. PSA generators are able to produce high purity of nitrogen, 4 nines or 5 nines like Robert was mentioning, capable of cutting thick metal sheets of steel and even stainless steel up to 11 gauge. Just real briefly, I just want to show you guys what a typical PSA generation setup looks like. You start out with a low pressure screw compressor, then a dryer, usually inside that compressor. This feeds an initial storage receiver. The nitrogen generator has 2 sieve beds filled with carbon molecular sieve, CMS, or coconut fibers. Nitrogen is then fed into a generator receiver. The high pressure nitrogen booster builds up the pressure required by the laser and is fed into the final storage tank, which the lasers draw from. In conclusion, how does in-house generation make sense compared to bulk providing? The further your customer is away from the bulk supplier, the more sense it makes. Kelly, in fact, would you like to share that experience of how you were able to see this difference?
Quick example, we had a report of a customer purchasing a $65 liquid doer in the Twin City area of Minnesota. That same liquid doer sold for $210 in Fargo, Minnesota, about 250 miles away, nearly quadrupling the price of that same liquid doer.
So Kelly, what you're saying is the further away the customer is, the more money they have to pay.
That's right.
So in-house generation makes sense there. You don't have the delivery charges, and the generation is right there in
That's
your
right.
plant.
Exactly.
Now, fab shops are a great opportunity for in-house generation, and this is what we found with fab shops. Fab shops are nimble, dynamic, and forward-looking. And because of that, fab shops look for any opportunity to save money and become more competitive. In-house generation is a great cost-reducing opportunity for the fab shops who's literally competing with the OEMs and the fab shop down the street. OEM manufacturers can be high users of nitrogen and can have up to 3 shifts. Because of this high usage of nitrogen, in-house generation makes perfect sense for them, and it's a great opportunity. The trick with OEMs, you want to talk to a decision maker who understands the entire process and the entire costs of the plant. I now want to turn the time back over to Robert for some additional technical information.
Thanks so much, Ken. We'll just briefly talk about some nitrogen compression solutions. There's obviously 2 basic compression solutions. One is oil flooded, the other is oil free. The key difference between the 2, of course, is the oil in the gas stream, which absolutely must be removed. We could spend the entire webinar on compressed gas filtration, so I really only want to touch on a few key points here. Aerosols are problematic in the 1 to 0.01 micron range, but fortunately a good coalescing element can take care of this. The problem in meeting Class 1 requirement then is the oil vapor itself. A properly sized and properly maintained activated carbon filter can then remove oil vapors down to 0.003 parts per million, which is well within the Class 1 requirement. But the important thing to remember is that activated carbon filters can only absorb a certain amount of oil vapor before the micropores on the surface are saturated. At that point, the filter is done, and oil vapor will pass through without impediment. Your customer may not even know it. Remember, DP gauges are not super useful in an activated carbon filter. As you can imagine, in our particular position, we've heard the stories of contamination to lasers and generators. The issue at hand is not the filtration, but rather the maintenance of those filters. Based on our experience, we recommend installation of oversized filters and the implementation of a rigorous maintenance program. Make sure those users are changing those filters regularly. Thinking on that, proper maintenance of the oil flooded booster is critical as well. to ensure minimal oil is being passed downstream to the filter pack. All right. So one of the newer solutions to nitrogen compression is the oil flooded high pressure storage. And this solution is actually quite clever for the right application. It consists of a feed air compressor dryer with a storage receiver, a small nitrogen generator, an oil flooded booster, and a 6 or 12 pack of high pressure, say 3000 psi storage bottles. The concept of this system is that the high pressure storage bottles are filled during the no load times, and during periods of higher load, the bottles can act as makeup gas. Because the most expensive component, the nitrogen generator, is sized smaller than the necessary for full load conditions, the initial cost is perhaps the lowest of all in-house solutions, making this system especially suited for smaller flow and intermittent duty applications. But because of its limited size and reliance on off times to fill that bottle pack, it may not be as suitable for multi-shift operations and offers less capacity for future plant expansion. And of course, filtration is required to ensure gas cleanliness.
Perhaps even a single shift running intermittently could benefit from this type of a solution.
Absolutely. That's probably your ideal installation, in fact. So the oil flooded full flow solution is something you are all probably very familiar with. A feed air compressor, dryer, and storage tank feeds a nitrogen generator sized for the full demand and possible future expansion, feeding an oil flooded booster, which then pumps up a mid-pressure, say 450 psi storage receiver. This is a mid-level entry cost as the generator is large enough to handle the entire demand plus possible expansion. Depending upon the oil flooded booster chosen, true continuous duty operation may be possible, making this solution a reasonable choice for higher demand, multi-shift, and customers that see growth potential in their near future. Of course, filtration is still required to ensure gas cleanliness. It's probably important to note here that there are a wide range of oil flooded boosters available with varying costs, varying quality, and varying life cycles. Do your homework with your customer to understand their needs and choose a booster that best fits those needs.
Just a real quick thought on this, Robert. While this is a widely accepted and certainly a perfect solution that works well, it's always been interesting to me to think of taking purely produced nitrogen at this 5.9 purity or however it is, and then potentially introducing that or exposing it to oil only to be cleaned up again before reaching the laser.
Absolutely. It seems a little counterintuitive. And I've even noticed when looking on the websites of some of our generator manufacturers, one thing they point out is high purity, high purity, high purity.
Right.
Interesting conundrum for sure. All right, so now we come, of course, to our favorite solution, the oil-free full flow. Again, a feed air compressor, dryer, and a storage receiver feeds a nitrogen generator sized for full demand and possible future expansion. An oil-free booster with a mid-pressure, again, 450 psi, say, storage receiver. And this is the highest entry-level cost, as the generator is full-sized and the booster is oil-free. But that cost doesn't differ hugely from a high-quality oil-lubricated version and certainly has some significant benefits. The Hycomp booster is a true continuous duty compressor with a 20-year life expectancy, making this solution a good choice for those same higher demand, multi-shift customers that see growth potential in their near future. A great point to make with your customers is why would they want to get out of that contract you mentioned, Ken, just to get into a regularly recurring cost for filtration? Why escape that same contract and end up with a booster that needs replacement every 5 to 10 years if they're a heavy-duty continuous user? Plus, as there is no oil in the compression chamber, we are not adding oil back to the already very clean nitrogen coming from the generator, which means no risk to your laser, no risk of contamination to your cuts. All right, so why are we the leader? Why are we holding this presentation? What makes us think that we should be doing this? The oil-free design and long service life made a Hycomp booster ideal for this application back in 2000. I personally sold our very first nitrogen booster accompanying an in-house generator to a manufacturing facility right here in Utah. By 2002, we had partnered with one of the first generator manufacturers, pairing our booster with their generator. In 2009, we formed a strategic alliance with a laser expert who had a series of representatives throughout the U.S. And just last year in 2016, we recognized that as the nitrogen generator market was beginning to become more competitive, margins and prices were dropping, and we started to look at how can Hycomp stay competitive. This year, we're excited to be rolling out our new Odyssey line, the result of a year of market research, engineered system redesign, and Six Sigma standard implementations to ensure that we are, and you are, competitive. But that Odyssey line still utilizes the same Hycomp oil-free booster design we've always produced. We start with a pressure lubricated bottom end, utilizing a full flow oil pump and filter, tapered roller bearings, rifle drilled crankshaft and connecting rods, with needle roller wrist pin bearings. What do you get for all this? You get a 20+ year life expectancy out of the power end. Next comes the distance piece that separates the oil lubricated end from the oil-free compression end. Ground and polished piston rods move through self-adjusting oil scrapers to ensure the oil stays in the bottom end, while the distance piece ensures there is no overlap between oil lubricated and oil-free. Finally, the oil-free compression end utilizes high-end polymer piston rings specifically designed for use in dry nitrogen, something we've learned about over the 17 years of compressing. Stainless steel plate-type valves, not reed valves, control the flow of gas through that compressor. And all castings are iron, not aluminum, to ensure good vibration dampening and good dimensional stability.
Let's get into a little bit more about the nuts and bolts of our Odyssey nitrogen booster line. We have 10 boosters available. There's pressure ranges from 300 to 600 psi on the discharge. Perfect for a laser, averaging a point of pressure of 300 to 400, so you have some storage capacity as well. And then a flow range of 500 to 12,000 CFH. Now, as Robert mentioned, this is the same compressor that we've been manufacturing all along. We are very proud to say that our compressors are made right here at our factory in northern Utah. That made in the USA is something that we are very proud of. As well, our parts are manufactured, stocked, and serviced right here from our facility in Utah. We have been able to standardize parts between models. This allows more availability to our customers, and we should note that a lot of our replacement parts ship the very next day. We have pre-designed packages including drawings and manuals. This is as close to off the shelf as we have ever been here at Hycomp. Also, reduced delivery times. We've been able to nearly cut our delivery time almost in half since 2014, coming in at an average delivery right now of about 8 weeks, which is right in line with your laser delivery and your generator delivery, your tank delivery, and so everything lines up just perfectly for your customer. Also, very exciting, you will be able to price your own system. And this is something that's new and has to do with this rollout and this sales toolkit that I'll touch on just briefly. This sales toolkit that we want to make available to everyone in attendance today has an easy sizing calc program, again, where you can size up your own system. We have 6 easy maintenance kits to cover cost of ownership and maintenance intervals to help your customers set up that critical preventative maintenance schedule, literature that you can share with your customer, improved installation and quick start, and then of course with every Hycomp booster system comes that lifelong factory technical support. Literally, we support these products for their life, whether it be 40 years or 60 years or more, we'll be here. So let's just cover quickly where to find customers in this market. Now, this first one might be kind of a given. It's to search by NACE codes and SIC codes in your area. The 31 to 33 series cover majority of manufacturing, so you can kind of dig in there. If you're interested in a fuller or more complete list, get a hold of us and we'd be happy to help you out with that. Also, as Ken touched on, these metal fabrication shops, sometimes known as job shops, where they are working, they're a bit more flexible. They're heavy users of lasers. So those are definitely a good potential. Also, original equipment manufacturers utilizing sheet metal in their product, all sorts of markets, aerospace, automotive, agricultural equipment, construction equipment, electronics, what's being manufactured in your region. And there's probably a need for a laser there. Another interesting thing I found at FabTech, I'll touch on just briefly, is the laser manufacturers. Now, in the past, the nitrogen was kind of just brushed off or kind of, brushed under the rug as a utility, and the end user had to go figure it out on their own. As nitrogen is becoming more relevant and the need for it and the volume is increasing, they are wanting to get on board and taking more of an interest in the nitrogen solution. So keep that in mind as well. Kind of piggybacking on that is the laser reps. These sales representatives, that have that relationship with the end user. They also want to be able to provide a full solution to their customer. It helps them and their rapport and reputation that they have with that customer to have a solution already available. So align yourselves with those laser reps if at all possible. We're going to take a quick second to kind of summarize. We've reached the end of this segment of the presentation. We hope that we have been successful in presenting some exciting information to you about the laser market in general and some of the growth that we've seen with fiber lasers, that we've been able to present some of the basics in actually how a laser works, which was fascinating to me. Also the importance of assist gas, that we've covered some types of solutions, not only with nitrogen being in-house, the various in-house nitrogen solutions, but also the solutions for the compression of that nitrogen to get up to the pressure needed for the laser. Also covering our new Hycomp Odyssey product, as well as some potential customers ways that you can find potential customers in your area. What we're going to do now is we're going to open it up to some questions and answers. You guys have posted a few questions as we've been chatting here. And again, we appreciate your time. We're excited to look at some of these questions. In the background, we'll just have a couple of our customers' experiences rolling. And we'll go ahead and jump into our first question. All right. How much air does a nitrogen generator need? Robert, that might be a Robert question.
Sure. That's actually a great question and probably best addressed with your nitrogen generator manufacturer. But to give you some idea, at a 4.9 purity, I want to say we were about 5-6 times air to gas ratio. So assuming that you had, say, 3,000 SCFH of nitrogen, that would be, say, 17,000 SCFH of air delivery to the nitrogen generator. Again, you'll definitely want to verify that with your manufacturer of the nitrogen generator. That's a fairly rough number.
But interesting how much air it takes to make that nitrogen.
Absolutely.
Yes.
It's a significant quantity. And as you go up in purity, say to 5.9s, that can jump to maybe 7 or 8. As you go down in purity to maybe 3.9s, that may drop to 2 or 3 or 4.
Wow.
So it is very dependent upon the purity of that nitrogen.
So what you're cutting would affect what type of pressure you're coming in at.
It does. I think most generators are not capable of constant adjustments. Again, something you have to talk about with your generator manufacturer, but most generators that I've been familiar with over the years maybe have 1 or 2 set points that you can adjust between if they've got capability, but they're not usually infinitely adjustable. The timing cycle of that pressure swing is very critical to holding that purity, the flow of the speed of the gas velocity over the carbon mole sieve. So it's really not something that's adjustable regularly.
Great.
Nice. Good. Let's move on to our next question. We only have a few minutes left with you guys today. And so let's take a look at what our next question is. Kaiser supplies a filter kit to achieve class 1 purity. Why would I want an oil-free booster?
Well, that's to the point, isn't it?
That's right to the point.
So I think I'm going to jump in here. I think the question is really, why would I want to spend the extra money on an oil-free booster? I know I personally can't emphasize enough the necessity to prevent oil contamination of the laser. Yes, I suspect not just aforementioned manufacturer, but probably most manufacturers of oil-free boosters can supply filter packs that achieve the required cleanliness. But again, will your customer maintain those filters? Will they maintain the oil-flooded booster properly, as I mentioned? Will you get a slug of oil coming downstream? The upfront cost may be only $5,000 or $10,000 difference for a fairly sizable Hycomp booster versus a good quality oil flooded booster. So that's a fight that every resale of our boosters has. We have to talk about that. Here's a thought to pose to you. Let's say you're financing your equipment, $150,000 finance fee to charge, to the cost of the original equipment, including the booster, generator, and tanks. Say you spend $7,000 more for an oil-free Hycomp, you're probably only $125 to $150 a month more to ensure that oil-free. And now you've removed the cost of those filters.
That's an interesting way that's a great way to look at it.
It's all about return on investment, like Ken was pointing out.
Definitely. Great. Another question, can the product be installed outside? Why, yes, it can. These compressors are incredibly robust. We do require some type of a cover over it, a lean-to or something like that, but they are absolutely capable to withstand weather. That cover is kind of to protect from snow and rain, things like that. If you have a side on it as well to protect from that side wind, that's advisable. But these things are good. We also have cold weather packaging. If it's a cold ambient, below freezing, we can account for that, as well as hot ambient conditions. So certainly outdoor installation is okay. All right, another question. Is there any filtration required on a Hycomp booster?
Go ahead, Robert.
That's probably a point we did miss in this presentation. While we don't put any oil into the gas stream, our piston rings are made of a polymer. That's a plastic, and as they wear, and they will wear, as they wear, that plastic dust then gets travels downstream. You do need a micron filter downstream of the booster. Size that properly. Don't put in the smallest one possible. Size it properly for the flow. You should get decent life out of it. Remember, a set of piston rings goes 8,000 hours. Ideally, sometimes 6. Sometimes I think we've seen them
12,
upwards.
30.
Right.
Yeah.
I was gonna say, I think we had one customer that got 27,000
Yes.
before they finally called us.
Right.
So it's going to depend upon your application, how fast those rings wear, dryness of the gas, etc. But they do wear, and that dust will go downstream and does need a filter downstream of the Hycomp booster. And whoever asked that, thank you. That's probably something we should add to our future presentation.
Now, just quick on that as well. So if you're running one shift, if you're just to put it in perspective, if you're running one shift a day, about 2,000 hours a year, it might be 4 years before you need to replace your rings. And then again, that filter is for the particulates from the rings, so not having to do anything with oil or hydrocarbons.
I'd just like to mention one thing. You may have sent in a question and we haven't gotten to it. Jackson, our IT man, is going to make a copy of those questions, and we'll make sure we get those questions answered.
Oh, absolutely. It's great point, Tim. All right, do we have any more questions?
Actually, our time's up.
We could cover this one super fast. ISC 1244. I think I have 45 seconds.
Oh, you should see it.
The last question is, how much is a full PSA nitrogen generation system? There's a variety of answers there, a lot having to do with your consumption, a lot having to do with whether that smaller size system is going to work for your application, also having to do with if the system is handling 1 laser or 2 lasers. Really, there could be a range of $100,000 system, all the way up to a $300,000 system if it were supporting 6 lasers or something like that. And so we definitely recommend getting in touch with your generator manufacturer for some additional information or training to understand some of those costs involved for the total solution.
Just to clarify, that would be the generator,
the whole thing.
The compressor, the generator, the booster, the tanks, etc.
Thank you.
Right.
Yes. Our typical scope of supply is the booster skid mounted, so the skid mounted compressor with an electric driven motor, a V-belt, the belt guard, necessary accessories and instruments, as well as our PLC based controls. So that's what our scope of supply typically includes. We have option adders as well, but we can talk more about that in detail as we get ready to send out these toolkits next week. So Ken and I will be working diligently to reach out to everyone who was in attendance today, and even those who weren't able to attend, to make sure that you get a copy of this presentation as well as this sales toolkit for our Odyssey line. We are absolutely so happy that you guys were with us today. One last note, now I'm 1 minute over, but I'm still going to say I have 45 seconds, is that we have a survey that we're going to be sending out to you today. Please take a moment and complete that for us. Let us know how we've done. Let us know your interest level. There's just a few questions, so simple. If you would please also forward that to the people that were in attendance in your group, and we would be incredibly appreciative of that. We thank you for spending your Friday with us. Everyone have a great weekend. And from the team here at Hycomp, we are signing off.
Thank you very much.